Okay, this is the second video to calculate to explain, the binary BPSO. As you see here, the binary BPSO, it is definition. The first thing is the problem definition. The problem definition to put some parameters and define some parameter like the number of decision variables, the size of the decision variables matrix, the lower band of variables and upper band of variables. As you see here, 0, 1, because we use the binary BPSO, and also we also initialize the BPSO parameter like the maximum number of iteration, the population size, swarm size, the BPSO parameters, inertia weight damping ratio, personal learning coefficient, and the global learning coefficient. And after that also we calculated the velocity of the swarm limits. And then we initialization some other variables that we can that we used in our program. In the first step, as you see from here to here, it is called the initial. Until here, it is the initial step of the binary BPSO. The initial, it is to initialize the position. It is randomly initialized 0, 1 to calculate the size, as you mentioned before, the size and the location of the size of distributed generation, and the location of distributed generation, and the size of the capacitor, and the location of the distribution capacitor. And this is the position that we initialized randomly as a binary values. And after initialize the velocity as a zeros of each position, and then we evaluated the load flow program and get it the fitness value from here and stored in the particle cost. And then we updated the personal best dependent on the position, the randomly position of the particles, and the fitness value that we get it from the load flow. And then we updated the global best. The global best, it is the best value of for all the particles. The personal best for each particle's position, we have the cost. It is now it is the best cost, but which one it is the best one for each particles position? It is the global, called the global best. So we compare between all the position or all particles and get the best one, the position and the cost. And after we finished from this repeated dependent on the number of population, and after we finished that, now we started the BPSO main loop. The main loop dependent on the initialization process. First we repeated that for the maximum iteration. Now dependent on the initialization step, updated the velocity of each particles, as you see here, dependent on the weight and the velocity, the previous velocity, and then also the random variable and the learning variables multiplied by the best particle position and the particle position, current particle position, and also the constant 2 and the random variable multiplied by the global position of the global best position minus or subtract from the current position. This is updated the velocity, and then applied the velocity limit, as you see here, and then updated the position dependent on the this equation that we used in your reference paper for the binary BPSO. There are a lot of equation for updated the position depending on the velocity for the binary, but in your reference paper we use this. So after that we calculated the new position dependent on your equation, and then stored in the particle position, and applied and reflected the mirror of velocity effect. And after that we applied the position limit. As you mentioned before, we have limit 0 and 1 for the position, because we are binary. And after we applied the position limit, now we calculated the load flow dependent on the new position, particle position, and get it the fitness value, the particle cost, and compared between the new cost that we get it from new particle and the previous best cost, and updated the personal best dependent on that. And also we updated the global best dependent on the new cost particles. And this is repeated the process for the whole iteration, and each iteration printed, as you see here, imprinted the best fitness value that we get it, and repeated that for the maximum number of iteration, and then we finished the iteration. We store the global best, or the best value that we get it from the optimization in the best solution, and printed also plotted how to the best fitness value behave with the iteration. And then we back to the main program, PSO program, binary PSO program, to print the result that to get this best in the load flow, to get the output result, and to get the optimization result. We hope it is clear for you. This is all for the binary PSO. The other program, it is the same. The difference, the only difference, it is the network specification, load, and the line data. In the next video, we go to through the other networks in generally. Thank you very much.